Hello, so I received a request to actually talk about DNS. So I'm going to talk about DNS the best way I actually can. So what does DNS stand for? So if you look at this, DNS stands for what we call domain name system. Yeah, it stands for domain name system, basically. So what is a domain name system? Domain name system is basically we use DNS to resolve an IP address. We use DNS to resolve, we use it to resolve an IP address, basically, uh-huh, we don't, no, sorry, we don't do that. We use it to resolve, domain name or a URL. Can talk about a specific URL and then we can use that to resolve it to an IP address. Yeah, so this is basically what we use DNS for. We're using it to resolve a domain name to or a URL to an IP address. Now, because the internet and all our computers, they use basically IP addresses. Even if you come here and you do this particular server, if you do nmcli, so everything exists. These are all the interfaces for this particular interface. So wireless connection, everything is an IP address, and even if you go online, everything is an IP address. But because we're human being, we are basically human beings, and with human beings, we can't start mastering all IP addresses. Yeah, so we have Google, we have Facebook, and then we have to master all those IP addresses. It doesn't make sense. We don't have that kind of memory. Also, what happens when Google changes its IP address to something else? Yeah, it's going to be a little bit ridiculous. So that is why we use domain name system. So it's like an address book. I'm going to use another analogy and say, you remember your phone number. You have somebody on your phone number. So if you come here, we have your name, or let's say we want to resolve your name to, let's say, to phone number. So how do you store? So for example, you have all contacts in your contacts, but you have like 500 contacts, but you can't remember all their phone numbers. So what do? You save them with a name that you know. So if I met somebody in an event, I'll call them somebody, let's say Jane, Jane Racing or WRC, so that you remember them. So when you want to call them, instead of actually having to remember, you click on their name. That name is mapped to their phone number. So when you click on their name, it leads to the phone number, and then now you're not calling the name, but you're calling the phone number, except the name is a link. That is basically what DNS is. Okay, good. So now we know that is basically what a DNS is. So how does DNS work specifically? What does it do? Okay, so for example, let's begin. So I want to type google.com, for example. I want to type google.com. I have google.com, google.com in this case, and I want to get to google.com. Yeah, so for me to get to google.com, I need to get to that particular server IP address. Yeah, but let's say I do not know it. Now, usually when you have google.com, usually we have what you call caching. So these things are usually cached closer to you so that you don't have to go all the way. But we're going to assume here that you have never accessed google.com on your particular computer. So what happens when you come from google.com? Yeah, when you come specifically from google.com, the next thing you're going to go is probably you have a browser now. Yeah, so we have our browser. In this case, we are typing google.com. In this case, we're basically typing google.com. Good. Okay, so everything is loading and stuff. Yeah, so let's say we are loading this for the first time. Yeah, so what actually happens now, if you're loading it for the first time, basically what happens is your browser is going to look for a local resolver. So first it's going to check your DNS. It's going to check your DNS to check, okay, it's going to check your browser cache and check does this browser cache actually have does it actually have this particular does it actually have this particular this particular IP address mapped to this particular. So if it does not find it because it's your first time, then it's going to move specifically to your local cache. So you have a DNS resolver locally, it's going to move there and check, does it exist? And obviously it's your first time, so it will not exist. So it's going to route that traffic again now to what we call a recursive resolver. So let's say this is your computer now. Yeah, this is your computer, and you've typed www. No, let's talk about bad. Let's talk about bad.google.com. Yeah, good. So we have typed that into our URL bar, and now we want to go. So we've said the first thing it's going to do is going to check locally. It's not going to find. It's going to check browser, find it doesn't exist. Then it's going to check local resolver, DNS. It's not going to find it. So after that, the next thing is has to go to what we call a recursive. It's going to go to a recursive DNS or resolver. So we're going to have something like this. We're going to have let's call this a recursive resolver. So we're going to call it a recursive resolver. So a recursive resolver is exactly what you hear it. It is recursive. It's recursive, meaning it does things over and over again until it finds an answer. Now, most of the time, a recursive resolver also acts as a DNS cache. So if you had done, let's say, bad.google.com earlier, it would be cache number 1 in your browser, another cache would be inside your local DNS cache, and then another one would be on your recursive resolver, just caching it to make sure things are faster. But in this case, this is the first time we're actually doing this. So it will go to this recursive resolver. Now, the reason we call it recursive resolver is because it is probably not authoritative for your domain. So what do you mean by authoritative? When I say that this DNS, when do I say that this particular DNS is authoritative? I say that this particular DNS server is authoritative when that DNS server has actual records for that domain. So a DNS is said to be authoritative when it has actual records for that domain. Yeah. So if it's not, then it's called non-authoritative. Meaning, if you go to a server that is non-authoritative, what it's going to do is it's probably going to send you back a link to take you to where you can find somebody. So if you go to, let's say, a new place and you want to find somebody, you don't know, you probably ask somebody on the road, and then the guy is going to ask, oh, you want to go to this guy? Go and ask that person. And then when you go to the person leads you to the other person until you get to the point. So you're basically the recursive resolver. You keep on asking for directions, and those other people you are the recursive resolver. So you keep on asking, and those other people keep on giving you guide until you actually get to the specific person you want. And that guy, we call him, that is the guy you will now call the authoritative name server. So it is authoritative in that it is the person you're looking for, or / it contains the DNS records for that particular URL. So when you go to, let's say when you go to now, we go to recursive resolver. So what happens when you go to the recursive resolver? Now, recursive resolver it's non-authoritative, so it's going to look somewhere else to find that. Now, where is it going to start from? It is going to start from what we call root domains. So we have root domains. It's going to look for root domains. Now, most of the time they say there are 13 root domains. Other people say that there are others that exist. So we go to root domains. So in order for you to understand root domains, I want us to understand what we call a fully qualified domain. So fully qualified domain name, FQDN. That is what we call a fully qualified domain name. So I want us to understand what that is. So what is an FQDN? This is a fully qualified domain name. So let's write, for example, let's say bard dot, let's say we can even say www.bard.google.com. So this is what I want to talk about. So this is bad.google.com. So if you go here, this is bad.google.com basically. We're good. So we want to go to this particular DNS. We want to go to particular this link where this link exists. Now, one thing most people don't know is that after every fully qualified domain, there is a dot at the end that is usually, the browser usually doesn't show you, but it actually exists. So if I come and do google.com, for example, in this case, google.com with a dot, it will simply lead back. So root domains, we have a dot at the end of each domain that exists that most people don't know about. So that is what we call root domains. So we have 13 root domains. We have 13 root domains, probably the main ones, or the ones that are being used anyway. Others may be special for anything. So when you basically when you want to go to google.com, so you are routed to one of those 13 root domains that basically will point you to where you want to go. So the first time you are www.bad.google.com dot. So you will go to the first root domain. Yeah, so the first thing you go to a root domain, and then you go to, let's talk about a root domain. You go to one of the root domains there. Then the root domain will tell you, okay, I'm not authoritative for this particular DNS record, but I can show you where to go. So you go there and you've gone to that particular one. So what it does, it will give you back an address. You have the recursive resolver. It will give the recursive resolver back an IP address of where it needs to go. And where it needs to go is where, okay, let's take this, for example, this. So this is the first one, the root. So it's going to return an IP address here. And then it will say, okay, I don't know where it exists, but I can take you back. Because this one has a top level domain or .com. So this is a root, and then we have top level domain, first level domain, second level domain. So it will basically, after this, it will give it an IP address to take it to where we have a .com top level domain. So that is returned, and then the recursive resolver will now go back. So here we were basically at root. Yeah, so we are basically at this one of the root domains which you are led to, and then they bring back the recursive resolver is basically given. Let's put in the recursive resolver here. Let's call this the recursive resolver, and then let's talk this one. So this is the recursive resolver. Recursive resolver. Recursive resolver. So it will go to the domain. So it doesn't find it bad, but it has found the dot, and then the root domain will take it back to where we have .com top level domain, and then that address. So what it will do, it will go back and then it will come back to, let's say this. So it will go back to that particular DNS server address, and then this one now has let's say a .com top level domain, and then when it goes there, we still have we have com dot, but we still don't have bad.google.com. So what happens? This one particular returns another IP address to the recursive resolver, which basically the recursive resolver comes in here and puts here, bam, and then it takes that IP address to go back to another DNS server address, and then this time it is led to, this guy knows where to get a top level domain called google.com. So it goes to Google. It goes to Google. So this was root. This was a dot, and then this is now a com. This was a com. This was a com dot. Yeah. So this was a com dot. So now this one will take it to Google. So this one will take it to Google .com .root. Yeah. But we need to go to where bad.google.com exists. So when it goes, this guy will know, okay, I know where bad exists. It is not here. I'm not authoritative, but I can take you there. So what happens? It brings back an IP address, and the resolver simply takes that IP address and gets here. And you have now, you have here now, you come back to where now it knows bad. We have bad.google.com root. And then when it gets there, this particular DNS server says, okay, I am authoritative for this particular address. Now I will return the IP address. and then it picks the IP address, whatever the IP address was. In this case, let's say 127, I don't know, dot 255 dot 17 dot, I don't know, 10, whatever the Google address is. Well, basically, I mean, let's talk about 217. Let's talk about something like 217. 217 dot that, and then probably that is the IP address. So it will return that to the recursive resolver because it is now authoritative. And then the recursive resolver will take it, it will cache it, and then after that, the recursive resolver will basically go back into the network, and then it will bring it back to our computer. Now, once it gets into our computer basically also stores that in its local DNS resolver, and then it also stores it in the browser cache. Yes, and now it has found the address of that particular DNS server. So that is just DNS resolution. So from there, now everything else can actually start working. You can now start to initiate a TCP connection, TLS connection, and now you can start transferring your HTTP headers. Yeah, basically. So now this is how DNS actually works. So DNS just basically maps an IP address. No, I mean, it maps basically a URL or a domain name to an IP address like this. And that is how basically works. So recursive resolver does this. So by caching, we don't need to go through this process. Now this process takes it takes very milliseconds or something like that. But usually caching them makes it even faster. So sometimes you can set up your own DNS server. Now usually most of the time a recursive resolver is that of your IP address. So your IP address usually sets up by default the recursive resolver. But sometimes it is not advisable to actually use your DNS, it is not advisable to use your ISP's recursive DNS resolver. Why exactly? Because sometimes they're insecure, sometimes they're probably overloaded, they become slow. So usually we have a lot of options out there for DNS resolvers. You guys know about DNS Cloud. So if you want to see what we were doing, so for example here in this case, we want to do a DNS lookup. So let's come here and say we want to do a DNS lookup. So we want to do google.com. So we're going to use a command called dig, and then we're going to do, when you do google.com, that is a dig command. No, this I didn't know there was a CM. So .com. So this basically returns DNS address. So here we have dig version on Ubuntu, and then global plus cmd. This is command. Then this is a header, tells you that query status is we are good, there was no error in that particular. Then we have this particular flags, and then pseudo sections with UDP. In this case, the DNS was resolved using UDP on this particular port. Yeah, so DNS basically uses both TCP and UDP for this particular case. And the question section. So what we were querying was google.com in this case, and we were querying an A record, for example, in this case. So this is the A record that is actually returned. And basically query time, we say 12 milliseconds. Yeah, and basically we actually good. So one of the things you can do is now we are at dig.google.com. So when I do dig.google.com, right now I'm using the recursive resolver of my IP address, which is Velcom. So if I want to I can basically use dig, and then I can use those public. So I have Cloudflare 1.1.1.1, and then I can say google.com. So in this case, I'm using that. Now, for some reason, using Cloudflare, I get query time of 128 milliseconds, which is ridiculous. Let's try and use Google's public DNS. So let's try and use Google's public DNS. Let's see, at 8.8.8.8. Let's do that. What do we get? We get 80 milliseconds. Let's do that again. What do we get? Now we get 12 milliseconds. So we got 80 milliseconds because we queried this particular record for the first time using Google's public DNS. So when you queried it for the second time, it was already cached, so it was basically 12 milliseconds. Do you get that? Let's try that again. So dig, and let's say amazon.com. What do we get? We get 84 milliseconds in this case, and we return this particular A records. But when you do that again, what do we get? We get 8 milliseconds because this was actually specifically cached. Yeah, so caching, that is what basically helps in this particular case. Now you can also check how that. So you can query dig, and then you have various records. So we're going to talk about records. So you can actually do, let's say, name server record or mail server record. So you want to see where do their mail go. You do that. What do you get? You get their mail server is basically 863 in 5 amazon.smtp.amazon.com. Basically, that is what you get. Yeah. And then if you want to see how the querying actually happens, you can actually do what you call a trace command in this case, and you can see we are going into m.root servers. We're going through these root servers as we are recursively requesting all this. This basically shows how the entire DNS process actually actually works, and that's very good. So we have basically we have DNS records that we can talk about. So there are various DNS records that we're going to talk about. The first one is what you call an A record. Yeah, an A record. So an A record is the one that we use the most. So an A record is basically when you add an A record is basically an internet protocol, an IPv4 address. So you're basically adding and saying, okay, for this particular hosted zone, let's say google.com, I'm adding an address, an A record for 192.something.com. So I'm just saying 217.25.40. Yeah, so an A record is basically an internet protocol. It's basically an IP address. So that is an A record. Another one is a quadruple A record added. So this basically just this is a record that points to an internet protocol version 4. So we might have those EF dot something 01, I don't know, something, F dot something. So this an internet a triple A record is an IPv6 IP address. So basically it leads to an IPv6 address. Then we have things like we have something like a CNAME record. A CNAME record is this is what we call a CNAME is an alias. So it's a CNAME is basically an alias record. Yeah. So a CNAME is an alias record. So for example, you might actually use a CNAME to basically redirect something. So you basically mapping one. Let's say for example, let's say like right now, bad. Remember right now we have Gemini. So bad was basically moved to Gemini. So bad.google.com. Now we can create a record and CNAME record called bad.google.com, and then we map that to basically goes to so a CNAME record basically maps a domain to a domain, and then it goes to, let's say, gemini.google.com. So everybody who goes to bad is automatically redirected to actually bad. That is a CNAME record. And then we have MX records. So we have an MX record which is mail. So where do you want your mail to be handled? So MX record just basically means mail server records. So it's basically saying, where does my mail go? So you can have something like zoho.com. You can say MX1. And then usually they come in like 2s or 3s where you have like priority 10. So if you do priority 10, and then you come here and do, let's say, I don't know. Let's say 20 mx2 dot zoho.com. And then even 30. So basically means that the smaller you have, this is priority. This is basically priority. Yeah, so this is priority 1. So the traffic to mail will be delivered here. Unless this is specifically having an issue, then the rest will be moved here. So priority 1, priority 2, priority 3. So this is a mail server record where your mail is actually done. What else do we have? We have so many records. We have what we call a PTR record. And a PTR record is basically just the opposite of an A record. So a pointer record, basically when we do an NS lookup, we are looking up google.com to find its IP address. But with a pointer record, we are basically looking for, we are inputting an IP address, and we are looking for its specific, we are looking for its specific URL. So that is a pointer record. So maps an IP to a domain. Yeah, so you probably don't know the domain name, but you know the actual, right? So PTR is used for the reverse DNS lookup. Now there are so many of them, DMARC records and all that. So those you can actually learn. This is as simple as I can make my my video on DNS. Thank you guys for listening, and thank you for coming to my TED talk.